Hello, everybody. Welcome to sigma.ai's and DigiEcoQuarry's webinar on AI, digitalization, and the future of processes in queries. Few housekeeping items before we start. For starters, we'll start in about 2 minutes from now. I spoke to Pierre and Lorena, and they can go until 40 past at the maximum. So if we have questions, I'm sure they'll be happy to address those. And yeah, we love questions. So we'd love to hear from you. Please use the chat function in order to do that. So let us wait a couple minutes for everybody to get in, and then we'll get this started. Please hold. Okay, so I see there's already a few people that have logged in, so I'm going to get this started to respect their time. So as I said before, welcome to sigma.ai and DigiEcoQuarry's webinar on AI, digitalization, and the future of processes in queries. My name is Sancho Atienza, and I'll be your host for today's webinar. I am joined by Lorena Vilades, who is a mining engineer and project manager for the DigiEcoQuarry project. Hi, Lorena.
Hi.
And by Pierre Plaza, who is an electronic engineer and who's the director of R&D projects at sigma.ai. Without any further ado, Lorena, if you could please start things off for us.
Okay, thank you, Sancho, for the introduction. Well, as Sancho has just said, my name is Lorena Vilades. And I guess that lots of you are wondering what an aggregate is. Well, aggregates are granular materials that are used mostly in construction, okay? They are sand, gravel, mainly crushed rock, but it also includes recycled and manufactured materials. They are essential components, and they are widely used for the production of concrete, mortar, asphalt, agglomerates, and other infrastructures such as roads, runways at airports, and railways. In our industry is one of the biggest, is the largest by far industry related to non-energetic minerals across Europe. We have 26,000 sites of aggregates across the whole European continent, and also 15,000 of companies, from which most of them are SMEs. Well, here are some facts, but I don't want you to be bored about aggregates. So please, yeah, thank you. So what is DigiEcoQuarry? First of all, DigiEcoQuarry is an EU-funded project by the European Commission. Within this project, we want to design, develop, and validate in 5 pilot environments an innovative quarrying system, which we have called IQS, which will comprise sensors, processors, and tools and methods for data capture, processing and sharing to provide an integrated, digitalized, and automatic and real-time process control for aggregate size. So long story short, we will build an online platform from which a quarry manager will be able to monitor in nearly real time all the processes that are taking place within the quarry. So with that said, what do we want to achieve with this platform? Okay, first of all, we want to upgrade the health, the safety, and the security of the workers by avoiding their exposure to dangerous situations by, for example, automating all the processes of the quarry. We also want to improve the efficiency, selectivity, and profitability of the quarrying operations by, again, digitalizing all the processes and the steps the quarrying process has. We also want to reduce the environmental impact of our sites by maximizing the resource efficiency, reducing the emissions, and improving the management of water. And last but not least, we will boost the social acceptance of our sector through the communication with policymakers and citizens. Well, for those who know nothing about quarries, this may be like the usual process of obtaining aggregates, okay? So first of all comes the preparation of the sites, because we have to remove all the overburden. Then is the extraction phase, where it can be done manually or mechanically, by mechanical means, or by drilling and blasting. Then it comes the loading, internal transport to deliver all these materials to the plant where the treatment takes place. Okay, and once the material has been treated, it must be stored. After the storage phase, it comes the external transport and delivery to the external clients. And when all the processes, and when there is, so to say, no more stone to mine within the quarry, it will come the rehabilitation phase, okay, of the pit. So here in this picture, you can see, well, we are a lot of partners. I will explain it afterwards, just right now. Okay, thank you, Pierre. We, in this consortium, we are involved 25 organizations, from which 23 belong to European countries and 2 are international partners, namely from South Africa and Colombia. And this consortium is not just comprised by mining experts or whatever. We are a lot, but we also have some technology experts, such as Sigma here hosting the webinar, and we have some relevant stakeholders which will help us also with all the policymakers and citizens related issues. We also have an international advisory board composed again by relevant stakeholders of the quarrying and mining industry, who will give us feedback and advice when we need it. And with that said, I will just introduce you to our pilot sites here in our project. We have 5 pilot sites. And why did we choose them? Well, the thing is that we want our platform to be replicable in every site across Europe, okay? And also it could be replicable to the US. Thus, we have selected 5 pilots which are absolutely different between each other. And for example, 4 of them belong to big companies. One of them belongs to an SMA. Others mine hard rock. Other is a sand and gravel pit. Another one is just a treatment plant. So, but let me explain it to you. Okay. Well, before starting, let me tell you something, that is that we will build within this project build some specific technologies for each site, but we will also deliver some cross-cutting developments for the 5 sites, okay? Which are the ones that you can see there with the horizontal arrow. Well, our first pilot belongs to Granulat Vicat, which is a big aggregates French company. It's located near Toulouse. And for those who don't know it, Toulouse, some years ago, was not the big city that it is today. So when this site was built, it was surrounded by nothing. Nowadays, it is surrounded by a McDonald's, a Burger King, and plenty of shops. So here they don't have extraction in the site, but they have the social issue problem. So we have named this pilot the public acceptance ones. So here we will develop the technology you can see within the screen, but also we will focus here on all the social aspects. Our second pilot is located in Madrid, in Spain, and it is a limestone quarry. And here we have named this pilot the drilling and blasting reference one. Why? Because they wanted to improve their drilling performance, the drilling and blasting performance. So all the things that we will develop here will be related to that. Then we have Pioltello San Bobbio, which is located near Milan, and it belongs to Holcim, which is a huge aggregates group. And this is not a quarry itself; it is a sand and gravel pit with underwater extraction. So the rock, it's extracted from down the water. Okay. And we have this pilot will be the reference one for crushing and optimization, for crushing and screening. So here we will develop a series of technologies related to that topic. Then we have CSI. I mean, we have Mamendor Quarry, which is an andesite quarry that belongs to CSI, which is an SMA. They have they've been trying to improve their energy efficiency related things, their consumptions. So they want to be like the most efficient quarry ever. So we will here develop some technologies to help them to achieve that best performance. Okay. And last but not least, we have another limestone quarry located near Lisbon, okay, in Portugal. And this is our reference pilot for transport and storage. So here we will develop technologies related, for example, to the for example, as a software which will help to monitor better all the material within the plant, some also the transportation, external and internal, and so on. And as I said before, besides all the specific technologies, we will also develop for the 5 pilots 3D BIM model, health and safety technologies, an environmental platform simulation, and we will install some social engagement strategy for all the sites. That will be all from my side.
Thank you. Thank you very much, Lorena. As you have heard, well, the project really covers a lot of technologies. In my speech, I would like only to address the digitalization part, okay, which is where sigma.ai is really putting an accent on all the activities on artificial intelligence and on the data that is captured by many devices. Here in this nice open pit representation, you see that there is a lot of machinery involved in the different processes, from the site preparation up to rehabilitation. All the different machines that you are seeing here, the wheel loaders, the drilling machines, the mobile trucks, etc., the plant that is very important in order to process the material, all of them have sensors, which are represented in blue here, the round boxes in blue. All of them have sensors. They are provided by specific companies. They have what we call expert systems, which are dealing with all the different processes, but specifically. So these are, let's say, closed solutions, which are dealing, for instance, with extraction or with the mobile machinery or with the plant machines that are treating the material in order to get the production running, and so on. So all these sensors are connected to specific systems via the cloud, and those are, let's say, closed gardens. But then what we are doing in the project, we are sharing the data from all these expert systems that are dealing with all these different processes, and we gather the data by designing a data lake, which is taking all kinds of data in different formats, and this data is then reorganized on the data warehouse. And from this data warehouse, where the data is organized in tables that can be further processed in order to get predictions, to get forecasting results, to get applications running, is what we are doing basically on the digitalization part. Where sigma.ai is participating basically in the upper part of this picture. This is a much simplified, let's say, version of the architecture. We have the different sensors that are installed in the different machines active in the quarry. Those are communicating, sending the data, the raw data, to different platforms, dealing with the different processes. And we are in the project designing a data lake, an IoT platform, in order to get information from sensors that need to be installed in order to process some information. And then from the data lake, we again message the data in order to organize it in tables that can be further analyzed by artificial intelligence models, and also analytics, in order to provide, let's say, solutions for the queries, in order for the query managers to actively see what is happening on the production, what they can change in the production variables in the plant or in the transport, in order to improve the production. No? So where are we, let's say, applying artificial intelligence from Sigma Technologies? We have basically 4 areas. The first area, we are developing a solution for document search and processing using natural language programming. So it's a document processing engine that is installed on the Quarries databases in order to get the answers to different questions. You will see the interface, and it's very easy to use and very handy in order to get whatever question you may have, all the information, telephone numbers, names of machines, codes, etc. It's very, very handy. Then we have the stock forecast area, where we are developing 2 services, one based in computer vision for a stockpile volume calculation using computer vision. I will go a bit more in detail later on. Then we are having a consumption and product forecasting artificial intelligence service, which is using the data that we are gathering, as I already explained, on the data lake and on the data warehouse, and analyzing this data and providing forecasts about the production and the costs that the query is running with the production, in order to see if they can produce at different times, if they can produce in a different way. Then we have a predictive maintenance and risk detection service, where we are detecting mechanical failures using sound capture and also vibrations. You will see also this, and this is very similar to predictive maintenance, but it's really getting information about possible failures that are occurring, for instance, in conveyor belts or in crushers, for example. Then we have the material quality and risk detection via computer vision. In this case, we are analyzing the quality of the material by using colorimetry, using camera vision, and we are also analyzing the grain size determinations in order to see how the plant is behaving in terms of production. The materials have the sizes that are meant to be standard in order to get the production going. And then we have a risk detection service, which is detecting objects and humans wherever in the pit, in the quarries, don't have to be. Okay. Good. What are the challenges we faced? Well, this platform, this IQS platform that Lorena and myself already mentioned, has to be affordable by all types of queries. Queries, they are really running very difficult, let's say, business numbers. They are running to the cents, so you have to be very careful with the cost of such a solution. It has to be connected to all activities. Try to connect all the machines and processes in order to get the data and then process it in order to get real-time indicators and reports. It has to be manageable by workers with basic IT knowledge. So it has to be easy to understand, easy to handle. It has to be adaptable, scalable, and replicable in order to be able to support all kinds of queries in principle. No, so it has to be exportable to different types of queries. We have in terms of in the project you have seen, Lorena has explained, we have 5 very different queries which are using different production processes, from dredging, from blasting, etc. Then they have to be able to work independently of any expert system, so commercial system. The system has to be open and be able to integrate new expert systems. Now I will talk about the results of the project so far. The project is 5 years long. We are already almost 2 years running. We have already some results. I won't explain in detail this architecture picture, but you can see that it is quite complex. We are developing an IoT platform in the project in order to get information from the sensors. We are developing a data lake in order to get the data in different formats and being able to retrieve it easily. And we at Sigma, we are developing a data warehouse that is organizing the data in different areas in order to provide data, easy data analysis, data mining, and data reporting in order to get dashboards that will help the different users in the query to see how the production is going, what they have to change, how good they have been, and what is the forecast for the next months or years. Okay. We are developing in Sigma and also with the help of the Universidad Politécnica de Madrid, a volume calculation service using computer vision. So you see here the result. We are using cameras, installed cameras in the queries in order to provide, let's say, almost real-time calculation. We are using also satellite images in order to make a comparison, and also drone flights, but only at the very beginning in order to characterize the queries. We have to be also, as I mentioned, costs are very important, so therefore we have to come up with a solution that is easy and not very costly, for the queries. We have the MetaQuery service, which is a natural language processing solution for document handling. So just by asking very easy and in a natural language, in different language, by the way, in the project, we have at least to handle Spanish, we have to handle Italian, French, German. And with this tool, we are able to handle all these languages in combination and get answers, not only the document you are searching for, but also what is inside the documents. And that is very, very key. So if you have a question and you cannot find the information, or remember that in one of the documents, there is something that you need to have, that this tool will get it for you. Okay. Then with respect to the mechanical failures, we have already designed a hardware that is able to acquire the sound and also the vibrations near the conveyor belts, for example, or crushers, in order to detect if there is a possible failure going on, or there is a failure. No? And this is already running, and we are running some tests, and it's just by analyzing using different algorithms, the waveforms that you are seeing now on the screen. With respect to the quality determination, we are analyzing, as I mentioned, colorimetry, so the colors of the materials, in order to understand how the blasting, for example, is being done, if the material that we are getting to the primary crusher is of the right quality. And also we are determining the grain size in order to also to see if the production is going according to what is planned and what is the standard. If there is a problem in the screens, for example, and the material is having some issues on one of the belts. Also in the project, we have a partner that is modeling, getting a beam model of each and every query of the project. And now, well, you can see how far we are in three different queries. Okay. So what are the lessons learned? Well, Quarries want solutions that are easy to use and maintain, that's for sure. I mean, they don't have IT expertise, and therefore we have to provide something that is not very costly in terms of maintenance, and it can be easily installed in different types of queries, and also depending on their IT systems and so on. No? So it has to be an open system. The data lake structure should have tools and metadata to easily track what is available. Why? Because in the data lake, you can imagine with having and getting the information from so many different expert systems that handle different sensors, different information. Well, you need a data lake that will help you by asking questions to get the data, and also some interfaces, some APIs, in order to get exactly the data that you're needing for your services. Artificial intelligence, as you can think, well, it's a must for such a system in order to optimize the production that is so important with respect to the cost that you're handling. No? And the business needs are really key, and artificial intelligence can help you really to focus on the business needs of every specific query, depending on the production, what you want to forecast, what you want to upgrade in terms of functionality, and also forecast for the future and see how your equipment is behaving, the transport within the query, etc. The solution should be replicable, that's for sure. And as Lorena already explained, the solution we are implementing is in this case for the whole Europe, but for the whole world, let's put it that way. But it has to be adaptable to many types of equipment and providers and so on, commercial solutions. So what's next? That's the important thing about such kind of project that is almost in the middle. We have to integrate all data producers within the data lake and the data warehouse. Is something that we are doing right now. So we are designing the different APIs, making tests that the data lake is getting all the different data that is produced by the different expert systems. We have to extract, to train the models that we are developing in terms of artificial intelligence, and design the dashboards that will be used by the query managers mostly. And finally, and it's, I think, the most important part of the project, we have to start the pilot phase. So we are putting and installing all the different features of the IQS, the Intelligent Quarry System, in the queries. In this case, it's on the cloud. But we have to start measuring, start providing results, see how the dashboards are providing real information, if the real-time information is what we are expecting, and so on. So that will be all from my side. If you have questions, please come forward. Thank you very much.
That's perfect. Thank you. Thank you, Lorena, for that introduction to the Quarries needs and to the project. And thank you, Pierre, for your view of the technology side with an AI focus. We do have a couple questions. Hopefully we can address those before we leave. I think one is probably more targeted towards Pierre, which is what challenges are you tackling to ensure data is ready for next-gen applications?
Well, in this case, it will be, as I mentioned before, we have to gather information that is coming from specific commercial systems that are really working in a different way. So the data has to be, in a way, stored using metadata that is, let's say, general for the whole data spectrum that we have. We have a very, very important data spectrum. And with all this, we are able then to generate tables from the, that's why we have chosen a typical structure for data analysis, which is we are using also a data warehouse that is getting the data in an organized manner, depending on the business questions that the queries may have. So this is the most important challenges to really assemble in one system many different solutions and being adaptable, replicable, and scalable. That's the most important challenge.
Thank you, Pierre. Okay, the second question I think goes for both of you, and it goes to why your companies chose to participate in this project, and what you are doing differently in your company from other projects. Lorena, maybe you want to start on this one.
Yeah, so since we are the Spanish Aggregates Association, we must lead intellectually our associates, so on the whole sector, in fact. So for us, coordinating this huge project is a major breakthrough, I mean, for the aggregates industry.
Thank you, Pierre.
Okay, good. Yeah, you can imagine for Sigma, I have to be honest, it was the first time we were invited to a mining project. So for us, it was an important challenge to come up with the solutions. We are used to provide, let's say, single artificial intelligence solutions. In this case, we are also developing, as I mentioned, a data warehouse that is key for artificial intelligence for the future. If you want to really handle big projects and a lot of data, that is key. So for us, it was a very good first opportunity to enter a vertical market that needs to be digitized, because it's something that we didn't mention, but the quarry industry is not very much digitized as a whole. We have seen that there are many specific solutions that they are developed, but the quarry process or the whole quarry business is not digitized because they don't have the IT knowledge that is needed. And we are providing a solution for them in order to do that. And for Sigma, that is really important. We are also facing different challenges in specifics, different services of artificial intelligence. For us, it's a very, very interesting project because it enables us to enter in different technologies that will pave the way for new business, I suppose, new businesses.
Yeah, I see how this is interesting, both for Sigma and for ANEFA, and I hope it was also interesting for those of you that joined us. Thank you, Pierre. Thank you, Lorena, and thank you to all of you listening in. We'll be posting this material in the sigma.ai webpage, as we will also be posting all sorts of information around the DigiEcoQuarry project. So I encourage you to check it out. Stay tuned. And thank you everybody for your time. Have a great day.
Thank you very much.
Thank you.
Thank you.
Bye.